In section 8.3, we're going to learn about elimination. So the elimination method is when we're going to add or subtract equations to cancel out a variable. So instead of substitution, we'll use this if the x and y are both kind of like stuck in the equation and there's not one isolated. So again, it's best to use when neither variable is by itself. So for example, let's say I had something like 2x plus 5y equals 20, and then 3x minus 10y equals 14. Again, we got to use either substitution or elimination because I have two variables or two unknowns. But again, I don't have an x equals or y equals, so elimination is going to be easiest here. So in example number 1, we have 2x plus 5y equals 17, and 6x minus 5y equals negative 9. So I'm going to focus on the y's because they have the same coefficient. So since our coefficients match up, that's going to be the easiest to get rid of. Other thing to note, opposite signs, we're going to add the equations together. And if we have the same sign, we're going to subtract. So since there's a positive 5y and a negative 5y, they have opposite signs, so we're going to add these equations together. The whole reason for doing that is I start to go down with the x's. 2x plus 6x will give me 8x. 5 plus negative 5 gives me 0. So that's how I get rid of that y variable. Then 17 plus negative 9 gives me 8. Now, I only have one variable, so I can solve for x. So I'll divide by 8 on both sides, and I'm left with x equals 1. Same thing as substitution. I still need to plug in to find for y. Again, it doesn't matter what equation you plug it into. I'm just going to go with the top one, so I'm going to replace x with 1. So I'm left with 2 times 1 plus 5y equals 17. Then I'll get the y by itself by subtracting 2, dividing by 5, and I'm left with y equals 3. In our next example, we have negative 6x plus 5y equals 34, and negative 6x minus 10y equals 4. So since I have the same sign here, I'm going to subtract. Also, I'm going to focus on the x's here again because they have matching coefficients. I see negative 6x and negative 6x again. Same sign, I'm going to subtract. Reason being, negative 6 minus negative 6 ends up being negative 6 plus 6, which is 0, so the x's cancel out. 5 minus negative 10 ends up being 5 plus 10, which is 15. So we'll have 15y, and then 34 minus 4 will give me 30. I only have one variable here, so now I can solve for y. I'm going to divide both sides by 15, and I'm left with y equals 2. Then again, I'll plug into either equation to solve for x. I'm just going to go ahead and plug into the top one. So I'll have negative 6x plus 5 times 2 equals 34. Then I'll go ahead and solve for x by getting it by itself, and I'll get negative 4. All right, in our last example, so we have negative 5x plus 9y equals 11, and x minus 3y equals negative 7. What's tricky here is that there's no matching coefficients. So sometimes in this case, we're going to have to kind of manipulate the equation to get something to match up. So notice here, if I multiply that entire bottom equation by 3, now keep in mind, if I multiply everything by 3, I'm allowed to do that. As long as I do the same thing on both sides, everything stays equal. I'm going to multiply every single term by 3. So now, again, I didn't change anything with the top, so that equation stays the same. 3 times x will be 3x. 3 times negative 3y will turn into negative 9y. And on the other side, 3 times negative 7 will leave me with negative 21. Now notice, now my y's match up. So I can go ahead and use elimination. Since I have opposite signs, I'm going to add. Negative 5 plus 3 will leave me with negative 2x. 9 plus negative 9 is 0, so the y's cancel. And 11 plus negative 12 will give me negative 10. One more step to solve for x. I'm left with x equals 5. And then I'll plug 5 in for x to solve for y, so I'm left with negative 25 plus 9y equals 11. Bring the 25 over, divide by 9, and I'm left with y equals 4.